past 8 years, and I'm mostly focusing on Scala and functional programming, and I love to see a talk like this. So please, guys, I give you the stage now, and the audience, use Slido or just raise your hands, and I will give you this mic, and you can ask your questions. Round of applause again, please, and then let's go.
Thank you very much.
Hooray.
Thanks, everyone. So we're sitting behind this desk because most of this presentation is going to be live coded. I'm going to be treating Duncan here like an agentic LLM and telling him what to do.
That's a good idea.
Thank you. So what we're going to look at is refactoring from quite traditional Java-esque object-oriented code into a more functional model. Functional programming and object-oriented programming are often presented as diametrically opposed programming paradigms, but in modern languages and with modern tooling, it's possible to gradually transform object-oriented code into a functional style to take better advantage of the type safety, to have more explicit data flow. So as our systems evolve, we can introduce and get the benefits of functional style to make it easier to then continue to evolve our code. And we can do that gradually without disrupting the work of our other team members who are also working on the code base at the same time as we are. So we will have a look at some code. We will refactor it. We'll share some techniques that we use for doing these gradual refactorings without causing widespread disruption or without going down a multi-day refactoring rabbit hole where the code remains broken for days and days on end. And then at the end, we'll try it again using a modern agentic LLM tool and see how that compares and see whether I can replace Duncan with a robot. Let's kick off. So we wrote a book together. It was secretly about changing our thinking about how we design software from thinking in terms of mutable state and objects to functions, and we disguised it as a book to help Java programmers learn what was then a new programming language, Kotlin. We're going to be demonstrating this in Kotlin. We have done these kind of transformations starting in Java and going all the way to Kotlin. This one would just go from Kotlin to Kotlin, and the same lessons apply. Duncan is a social media influencer and has a very popular YouTube channel in which he covers the same topics and many others about being a good programmer. Okay.
Oh, yeah. Good programmer.
So what are we going to do? We are going to look at a web application, and it has an object-oriented design. It uses beans, for those of you who use Java. We're going to transform it into functional design. We're going to make error handling type safe. We're going to work in small steps. We're going to avoid breaking the application for more than, ideally, a few seconds at a time, unless we really fluff something up during our live coding. Okay. The application we're going to look at is for signing up for workshops at a conference. So you can imagine that we've got our apps as people attending a conference, and in the app we can see the workshops that we might want to sign up to, and those workshops have limited capacity depending on the size of the room that they've been scheduled into. So we can sign up, we can cancel sign up, and after some period of time the administrators can close the sign up, and at that point we've committed to paying for that workshop, and we can't cancel our sign up, and we can't add anyone else, so no one new can sign up after closing. So that we are going to be focusing on the core of this architecture that we see on screen, the web application that receives HTTP and JSON requests and stores the sort of information about the sign-ups in a database.
I said a lot more in our practice. I'm beginning to feel a bit like Teller.
Okay. Enough talk. Let's look at the code.
At last, right. Oh, no.
Oh, that's not the code. We'll take that out in post.
Yeah, it's all good. Okay, so here we are, and do you want to look from the inside or the outside?
I like to work from the inside. Let's start with the domain model, right? And then we'll work out looking at how is that domain model used in a wider context, how is it used in the web application, and so on, right? So our core concept in this application is a sign-up sheet. So there's some kind of metaphor here based on people signing up on a physical sheet. Right? People can sign up there. Well, let's have a look. The sheet is about a session that's identified by a session ID, which you could imagine being used to look up information about that session in a wider conference management system. It has a capacity, that's just a number, and it has, what else does it have, Duncan?
Well, sign-ups, basically. So its job is to collect the ID of people attending the conference into this set of sign-ups, and you get that by calling this sign-up here.
Yep.
And you can also undo a sign-up down here, and those things just basically, they have to check that it's not closed or full or that sort of thing, and then just really put things into this set. So that's easy enough.
Yep, and we can close it, right? There's a Boolean flag to say whether it's closed, and if it's closed, you can't sign up. Okay.
But irritatingly, like, you can't sign up when it's closed, and you can't sign up when it's full. So we have these checks, which are Kotlin things for just like throwing an exception, basically. We're done. What can we do?
Now, a sign-up sheet, multiple sign-up sheets, one for each conference session. They're collected into a sign-up book.
Oh.
So let's have a look at sign-up book. So sign-up book is our persistence abstraction. Can everyone read the code okay, or do we need to make it bigger? No complaints, some thumbs up. All right.
Okay. Good.
So a sign-up book is, there's some domain-driven design. That's a repository, but we've got some sort of domain terminology there. So we're calling that a sign-up book. So a sign-up book lets us find a sign-up sheet for a conference session, and then using that sign-up sheet, we can sign up or cancel a sign-up. And we have, what are you showing? An in-memory sign-up book that's simulating a database so that our in-memory test can run super fast. So we've got some tests that, thank God, they run. So our tests pass. They are testing the domain logic independent of any infrastructure concerns. So we've got some hexagon architecture going on. And because of the in-memory sign-up book, they are running pretty quick. How many milliseconds for a test run?
That many.
That many. Shorter than I can count. So, and then the sign-up book, that's going to be used by a sign-up app. So this is an HTTP4K web application. An HTTP web application is a function from HTTP request to HTTP response, and it's responsible for routing that HTTP request to a handler that can handle it, for performing transactions and business logic and other things. So should we have a look at what that app does?
Certainly. This is all there is to HTTP4K, so collect your certificates on the way out. You're now trained HTTP4K programmers. Sign up app. So we have some routes, and we bind these sort of paths to something that takes a request and return the response. So you get responses like OK with the body of take all the sign-ups, put them into a string, and then send them out over the wire. And something here, some cleverness around a transactor, and the transactor's job it is to go and find
It creates a transaction boundaries in our database.
Okay, but it finds a sign-up book for this request, basically. So every request has the session ID in it somewhere.
Yeah. So you can't use a sign-up book unless you're inside a transaction. So there's some type safety there around our transaction boundaries. But this is all very, although it's server as a function is what HTTP4K describes itself as, this is actually quite procedural. We're starting a transaction, we're getting something from the database, we're working with the sign-up sheet that we want to change, then we're saving it back in the database, and then we're returning an OK or whatever.
And then down here, so here is sort of sign up. So this is a sign up path, and if you post to that, then we go and get a sheet here somewhere. If we can't find it, we say, and then here, we say, look, go to the sheet, sign up this attendee, and then we have to save that book back into the database.
And we have this try-catch, right?
Oh, yes. So we have these illegal state exceptions. So those are the way that so that code can fail, I guess. And I guess if we were to find those in the code base, we could see where they were thrown from, except that they aren't thrown any. So we catch them, but we don't throw them.
Yeah.
Do you know where they're thrown from?
I do.
Okay.
But this is one of the things I don't like about this code, right? It's very hard to tell whether we actually have code that throws these exceptions, and whether these are all the exceptions that are possibly caught. So Kotlin doesn't have type-checked exceptions like Java did. All exceptions are unchecked, and when we call the check function, that throws an illegal state exception, and we just have to know that that's what happens, and that those are the only exceptions that are thrown. So that gives us extra testing overhead. We have to write more tests, we have to run more tests. HTTP for K, because it has this model of HTTP handling, which is just a function from request to response, lets you run tests in memory. You can create request and response in memory and then exhaustively test your HTTP handling and application code very quickly. So the speed is much better than using some frameworks. But I still have to write all those tests, and I would much rather that I could use a type system to prove properties of my error handling, and then have a lot more confidence about I've covered all the cases and I don't have dead code.
Okay, so this is the sign-up sheet, and as well as this problem here with it throwing exceptions when things don't work and us not really knowing what they are, it is also unfashionably mutable.
Yes.
So like we've got this vars, and vars in Kotlin are variable. They're properties, they have getters, and if they're vars, they have setters as well. And so the session ID is, we can change the session ID, we can change the capacity for some reason, although it feels like that's a thing you only should do when you create the session. The sign-ups, you can't change the sign-ups, but it's pointing to a mutable set, so you can change you can add and remove things from it. You can change whether it's closed, you can change practically everything.
So if we want to introduce type safety, I would want to model these different states. So we can see here that we have a sheet, and the sheet can be closed. It can transition to the closed state. There's things that it does when it's full that it doesn't do when it's not full. So there's another state transition between full and not full. And I would like to not even have the sign-up method, for example, when a sheet is closed or when a sheet is full. And in order to model that, I would need to model that as a sealed class hierarchy in Kotlin. It's like an algebraic data type. And I would need to model it as an immutable data as well, because if the state can change dynamically, that dynamic change has no model. It's impossible to model that in the type system. So to be able to model the state changes in the type system, I'm going to have to make it immutable. Right? So the first step is, let's make it immutable. Right?
Yeah.
Then we can work out how to introduce some better type safety so that we can eliminate the exceptions and have a clean and easier to understand model.
And then we can go home.
And then we will try it again with an LLM.
There were two questions. I just wanted to ask them. So can we have a link to the repository, please? Is it a public repository?
We will give that to you later. How about that?
Yeah. Let's get to the point where we can do some coding.
And there was another question. When is Growing Functional Software Guided by Tests going to be published?
Nice try.
Right.
We done?
Yes.
Okay.
Right. Okay, so enough highfalutin, abstract data type stuff.
Yeah.
I'm offended by the mutability.
Yeah.
Let's just get rid of that.
So there's some mutability that's necessary because that's the business logic.
So
and there's some that just seems to be Java habits left over. This is models of Java Bean. It's got a constructor that takes no arguments. So to set those fields, they have to be mutable, but we don't actually use real Java beans in this application. Very many times I see code where people just define no constructor, getters and setters, because that's the way coding is done in Java, and this has happened here. So let's clean that up first, then we can see the wood for the trees and work out what the actual mutability is and how we're going to get rid of that.
So for those people that aren't Kotlin programmers, there's a sort of hidden constructor here that you can put in or take out. And so there is this no-arg constructor, the default constructor, and then there's this constructor here, which we call a secondary constructor that's calling the no-arg constructor here. So the question is, does anything actually call this one? And we can have a look. And what have we got? New instance creation. There. We've got in our main, for some reason, we create a sign-up sheet and then we set the properties on it. It's like,
So we've got a little test server there for people to do some manual testing, right? And it creates some dummy data, and then people can play around with the HTTP APIs, Postman or something. So,
but it's like the 1990 calls, and it wants its code back. So I'm going to fix this. So Kotlin has this like apply. So if you want to like initialize an object, normally you'd do apply, and then you'd move these two up into here, and then inside there, that would be the object that you called apply on. So that would kind of be the same thing, and we can prove it by running the tests. And then we're in a position to say, well, actually, we don't want to call that constructor and then just set these two things. Let's just take those two lines basically out of there, put them in there. There's going to be an irritating comma because, I missed it. And then we can don't care about that thing. And then that should be, okay, good. So we've fixed that, reformat. And now I can go back to here, and I think that constructor should be unused. So remove redundant constructor. Yes, it's not telling me that that one is redundant, but I'm going to take a punt. I'm going to get rid of that. I'm going to get rid of that. And if that compiles, it wasn't needed. And
test or pass.
We're good. OK, excellent.
So let's turn that into a primary constructor.
OK, so primary constructor, I think that's just a thing. OK, do that. OK. So primary constructor tells us what the types and sort of defines the signature of the constructor and the properties inside it all in one go. So we'll do that and something like separate lines because I'm allergic to that. OK.
So now we've got the capacity has got this guard on the setter to make sure we only set it once. But if we make it a val, because is anything setting it more than once?
Okay.
Well, it can't, but
no,
because I test bar. So
okay, so we can just basically
now we know it's being initialized.
Try making that a
something.
val, and then that means we can't set it, so we get rid of that, and then we might try that. It's all good, and then I can move that into the constructor like that. Oh, right, that's quite pleasing. And the session ID, I guess that now we don't change either, so maybe I can make that.
And we can make it non-null.
Let's do one thing at a time. I like to run the tests. So fast, I spent all this time. OK, so I've got rid of that. And then, as you say, the only reason that session ID was null was because we needed something to set it to if we hadn't set one at all. But now we always have to set one. So I can make that. So these question marks in Kotlin are nullable types. And I think, actually, if we were to look at this just before we do, then you'd see, I'll move that up a bit. When we read it here, you can see that when we're saving a session, we can only save a session that had an ID. So if the session ID was null, we use this Elvis thing here to say, OK, that's an error, I can't save it. But if we'd go back to the sign-up sheet, then we could say that's not null. And then if we went back to where we just were, then that's unused code now, because it can see that it can't be null, so it don't need that, so we can get rid of that. Hooray. Good, and now that's simple. I guess I can just inline that thing like that. Is that worth a commit, do you think?
Yes.
Ooh.
What does the AI think we've done?
OK, so we're going to ask AI Assistant, and it says we refactored sign-up sheet and updated related usages. We simplified it by replacing the secondary constructor with the primary constructor and converting. I mean, it's all true.
It never says anything bad about what you've done.
But it hasn't judged. It hasn't said it's good. It hasn't said it's bad. So we're just going to commit that, I think. Oh, and go on. OK, well, there's some keystroke I'm not using. Good.
OK, so we can now see where we actually have mutable state, right? Which is what is closed.
So we close things, and we mutate the things inside the sign-up, and that's it, because it's only really closed. Can I move these into a primary, into the constructor? That would make things a little bit nicer. And is closed, so private set, what does that mean?
It means that you can read it from outside the object, and you can only set it inside the object. But you can always just close anyway, so we could just make it always public.
OK, so if I get rid of that, then I can probably just pull that up into the constructor as well. And that then feels like a good order, right? So we've got these properties. We've got the session ID, which we can't change. We've got the capacity we can't change. We've got the sign-ups, which we can add and remove things from. and we've got whether it's closed, which starts off as false, but when we close it, it's true.
Yeah.
And there's some reason IntelliJ did a thing there.
So now we're going to start turning that into a functional model, as in immutable data, functions that transform the data rather than operations that mutate data inside an object. And doing so will push that mutability from the very core of our application outwards so that the core of our application becomes pure calculations, and the actions that are causing state change side effects are moved closer and closer towards the entry point of our application until eventually only the entry point is the thing that's coordinating actions and everything else is pure calculation. Pure calculations are a lot easier to reason about, to work with, to refactor, because we don't have to care exactly when they happen, while the actions, it really matters when they happen or if they happen or not. So the more calculations we have, the easier it is to understand what's going on in our code base.
And functional programmers call these calculations, they're pure functions, they are referentially transparent, they have no side effects, all that jargon, but we like calculations.
Okay, so let's start with that mutable set. Right?
Okay.
We can move, that's the most innermost piece of mutability in our system, and if we turn that into an immutable set, and instead, when we add and remove elements, we'll transform that set into a new one, we'll have to store that new one in a mutable variable of our sign-up sheet. We'll have moved that mutability outwards one tiny layer. Right? Once we've done that, we can start doing the same thing to the auction. Move its mutability out one layer by replacing all its mutations with transformations.
Auction, are we back yesterday?
Oh, auction, that's what I was doing yesterday. Sign-up sheet. Yeah, we'll have to take that out in post as well. Right.
So, so the problem we have is that even if we make all of sign-up sheets, all of the bits of sign-up sheet, these things immutable, if they point to something that's mutable, we still have to worry about state. So we don't want to do that. We want to fix this to be just a set, right? And if that was a set, and then instead of mutable set of, we can say empty set. And again, it laughs at me and puts in that. And my problem now is that I can't add to an immutable set. So Kotlin default collections are immutable. But what I can do is I can say that my signups is now a new signup. So I'm going to say its signups is the old version of signups plus the attendee ID. And there's only one problem, that's that I can't change the signups, but I'm just going to make that OK. So we'll change that to var for now. It's going to get a little bit worse, and then it's going to get better. And we're going to do the same thing down here to get it to compile, and that's going to be signups equals signups minus attendee ID. And this minus and plus are just giving us a new collection with the old collection with this thing added or removed, rather than mutating the collection we had. Does it pass? Woo-hoo. OK.
OK, let's commit that.
Good. And so that was make signups immutable in signup sheet and refactor immutable. Well, I mean, close enough. OK, right.
So now we want to apply the same technique, but to the sign-up sheet. So we make those vars into vals. We make the operations into functions. So let's start off with what? Sign up and cancel sign up.
If we survive.
Yeah.
So the basic idea, I think of this as object-oriented programmers, we were used.
We lost. We've lost a.
As object-oriented programmers, we're used to having this. It's very hot. I'll unplug.
Are we back?
Well, something changed. Aha, right, OK.
Right.
As I was saying, as object-oriented programmers, we're used to seeing this sign-up sheet as representing a sign-up sheet, and so we add things to it and remove things from it, change its state. Functional programmers think of this as data about a sign-up sheet. So it doesn't actually represent the sign-up sheet, it's a measurement of the sign-up sheet, or like a prediction of what it's going to be. And in that case, if we want different data about a sign-up sheet, then we copy some data from an existing one and we change a thing so we get a different sign-up sheet. So that in functional programming, we try and work as far as we can with immutable data, which we see as I say, a measurement or a prediction.
Yeah.
So if we're going to do that, then we need these operations to return a different sign-up sheet.
Yes.
Yes, and we're going to make that happen here just by saying, look, let's return this for now. So it's the same thing.
What we're going to do, while you're putting the thises in, is like if we just went and changed it all, that would be a big change. It would take a long time, and if other people were working in this code base as well, and we would be disrupting their work and then causing merge conflicts. So what we want to do is, like, similar to how we would do expand contract releases of a system into production, so we do multiple evolutions of the system without downtime, we can sort of do the same idea with refactoring. We'll introduce multiple parallel structures that allow the old way and new way of working to coexist. We'll talk to our team about what we're doing. People will migrate and will migrate across the code base to use the new way of doing things. So in this case, we'll say we're going to make it pure functions of immutable data. We'll make it the operations look like functions. Then we'll start using them as functions. Then we'll finally make them functions. And at that point, the whole system will just work. And Duncan will demo.
Okay, so we've not changed behavior at all at the moment. We've just changed that signature. And now what we're going to do is we're going to go and see who calls this. There are two places. I'm going to say, if you were to have a new object, rather than just continually reusing this old one, how would you change? So we look in sign up app, and you can see here that we are taking a sheet, we're signing up, that's mutating it at the moment, and then we're saving that sheet. But if we were to get new data about a sheet, that would be like updated. And then we'd have to save that updated thing. So we're going to prepare for that by making the code like that. But that's still going to pass the test because we would just, it's all referring to the same object at the moment. And we'll leave that there for now. That's good. Let's go back. There was one other place I think that was being called, so we're going to fix that up as well. In-memory sign-up book. OK, so here we've got this odd sort of clone thing. So we're trying to pretend that we've gone off the database so that it just, all the data about our sheet got serialized as strings fundamentally, went over the wire into the database so that what we're trying to do is make sure there's no aliasing in this book. I think we can, at the moment at least, make it so that we move the signups into here. So we take the signups and put it into the constructor.
So now the signups are immutable. We can just copy it across. We don't have to copy it into another immutable set.
Yeah, so we're reusing
two references to the same immutable data doesn't matter.
So that's still working, and we're reasonably confident with the test, so that's good. What we're going to do now is go back, and there's still a danger that we are relying on aliases here. So instead of returning this at this point, we're just going to copy this. So we're going to take a copy of it to return it, and that will make sure now that the code around us is using that copy. We can't copy, but we can if this was a data class, and as we're working towards data, that doesn't feel too bad. Yeah. We don't normally like data classes with variables inside them, because what does it mean if you put something in a hash set, in a map, and then its hash code changes, for example? But again, it's going to get worse before it gets better. We're trusting, but maybe we wouldn't push this so somebody else saw it in the meantime.
Explain what we're doing to the team so they don't start copying the same patterns. Or
now then, we know that we've mutated this object, but we suspect that nobody can be actually depending on that mutation, and we've copied the object so we know that nobody can be depending on it. So we can basically take this code here, the one that mutates this object, and make that the new signups in the copy that we're returning. And if that works, then yeah, we're kind of cooking on gas. Shall I do the same thing in cancel before we go on?
And then we can commit it.
Yeah, right. So basically the process is we say, return this as if it's going to be a different object. Change that type, that's good. Go and find out who calls this. That's in only one place here, so we can say, there's this nice thing where you can say .val, and then that will create a variable that you can say new signup. I like that. And then So it's the new sign up, or well, whatever, the new sheet, basically, we want to put in here. If we're right, then that's all good, and then I can take this one and inline it, and then get rid of that one, and I think I can do the same thing up here, so I'll inline that, and remove the variable. That would have been better.
Great.
Okay.
So now our manipulation of signups is entirely functional. We've got to do the same thing for the closed flag.
Okay, can I commit this one first? Yeah, I'm going to commit this one first anyway. Sorry? Oh, no.
Ooh,
Thank you.
good point.
It's a good job somebody's. Right, let's do that bit. So are we going to go straight to this dot copy? Signups equals signups minus attendee ID. Tell you what, I'm just going to see whether our tests work. Ooh. But we'd already mutated out there.
Yes.
Okay, we still keep our test-driven developer badge. And okay, good. Thank you very much. Saved.
So now we need to make signups a val.
Oh, I can do that before I check in, I suppose, can't I? So signups now is not changed anywhere. We think it isn't. It's hard to tell. We could do this thing where we go.
If we make it a val and run the test, we might be able to see.
There. So we could find right usages here, or the easy way is just to say, does the compiler tell us we can't do that? And the compiler doesn't tell us we can't do it, so we can do it, and we did it. Woohoo! Does that change anything about the message? No. Commit.
All right. And I think we will apply the same technique to close. So instead of changing the close flag, we will return a new copy of the sheet, but with close set to true.
Okay, so I'm going to say return this. I say make that do that. Find out who closes this. So 2 places, the sign up app does sheet close and then save. Well, I know now my pattern here, so I can just take this thing, cut it out of there and put it into there. Run the tests, go back, say return this dot copy, closed, is closed equals true. Take out that.
But are we sure that's the only place that calls close?
No, okay, so, well, test for the win, because I should have said there was another one, which is in-memory sign-up book. Okay, so here again, we were using close to set the flag. I think basically we can say, if it is closed, well, we can pass is closed in there basically now, can't we? Like that, we get rid of that. That should make it pass, and does, then we can inline that. And then basically there is no difference between cloning a sign-up sheet, it is just basically...
So now when we make closed entirely a val, right, have we done that?
Yes. I mean, as soon as I do this.
So do that. So now our in-memory model of our database, our simulation of the database, it's just storing a hash map of our sheets, right? And it was cloning those values because parts of the code would change the field values of the sheet, and if it was stored in our pretend database as well, it would magically change what was in the database. And so we were cloning it as we read it out of the database so that we would simulate what happens in a real database, and we wouldn't have these aliasing bugs caused by the mutation, basically giving us false positives in our tests. And now it's immutable. We don't have to do any of that cloning because we can't change it. We can just store those particular values keyed by the ID in a hash map, simplifying our simulation of our persistence greatly.
So we probably find that out by inlining that. That, for some reason, ends up with a let, but we run the test anyway. That's all good. And then IntelliJ says that let's not required, so that's still good. And then this is no longer a relevant comment, and this becomes that. Okay,
right.
That's a lot simpler. I like that. Commit that one.
Okay, and have we made everything a val? I think we did.
Oh, I think I did. Val, and this is immutable.
Yeah.
So this is now properly value.
Yeah.
But it's properly value providing that the session IDs and the attendee IDs can't themselves be changed. Should we go and check?
We've gone from a bean to an object with a constructor to an entirely immutable model with functions transforming it and and the rest of the application treating it as in a functional style in about half an hour. And I don't think we broke the application for any more than a few seconds at a time. And we did so in a way that would, if we were in a bigger team, have not broken the work of other teams while they were working on the same code base, right, until we could come to an agreement about now it's safe to do the next change. They've committed, we've merged, and what have you.
But we still have exceptions.
Yes. So the next bit is, what are we going to do about those exceptions? I don't like the fact that these functions are not total functions. Right? So all the methods on this object are just pure functions. The sign-up sheet itself is like an implicit argument, but it is just a parameter. These aren't even polymorphic calls in this code base. So these are pure functions, but they're not total functions. What that means is for some elements of the input set, the domain of the function, there is no result, and instead the function throws an exception. So we have two strategies. How do we turn a partial function to a total function? We have two ways we can possibly do that. One of them is we could widen the codomain. That is, for those members of the domain set for which there is no member of the codomain, we make the function return a new data structure where we can model these failure states. So we could have an algebraic data type, an either type or result type in different languages, and we either return a success, right, of the result, or we return a failure of some code that represents a failure. So that's one way. So we could widen the codomain, or we can narrow the domain. We can say we have functions that only apply to certain types, and we have a subtype hierarchy where we know that there are only certain subtypes of sign-up sheet, and in particular subtypes, only in those subtypes do the operations apply that apply to those subtypes and don't apply to other subtypes. That's the approach we're going to take in this example. So we want to model the state transitions as different types in a sealed type hierarchy, and then the operations will only be defined on the type for which they work. And then the further out in our application, they will have to use a type conditional, a when statement in Kotlin, and to check what the type is and decide what to do when they're trying to do something that only applies to some states to a sign-up sheet that's in a different state. So just like we're moving the mutation outwards towards the entry points of our application, we're moving the error handling and sort of state checking outwards towards the entry point, where we're already doing actions and I/O and handling errors, and also where we have more context about what we want to do with that error and how we want to report it. Right? And we don't have to tunnel that information through an untyped exception throw and catch.
Wow. I put your diagram up.
Oh, yeah. So this is a state machine. When we create a new sign-up sheet, we start off with availability because we have no sign-ups. Right? When we sign up, then if we have the number of sign-ups is less than capacity, we remain available. If the number of sign-ups is the same as capacity, then we are full. We can only sign up when we're available. And if we close in either of those states, oh, thank you, Duncan. An LLM couldn't do this, could it? Then we move into the closed state, and we can't sign up or cancel sign-ups in that state. And if we are in the full state and we cancel, then we make a space available and we go back to the available state. Right? Now, that can be represented in a sealed hierarchy.
Hold on. Go back. Just before you do, so I think it's worth saying that the issue here is that these are our methods, right? Things like cancel, sign up, and so on. But these are all available on the same class, on the sign-up sheet. So we can't take them away. All we can do is say, well, if you're in the full state and you call sign up, we fail. But that sign up method is always on sign up sheet. So that's the reason we're having to throw these exceptions.
Yeah. So we want to translate this state machine, these states and transitions, into a hierarchy of types and functions, where sign up is only defined on available, close is only defined on open, and so on. And we have this direct sort of correlation between like state machine and type hierarchy. Should we go back to the code?
And if it was just as easy as Keynote's magic move, it would be a lot nicer.
And again, we want to introduce this bit by bit. We don't want to break everybody's code as we're doing so. And we want to not break our own code for very long while we're doing so. Now, in Java, IntelliJ has a lot of really useful refactorings for making these kind of transformations that have not yet made it into the Kotlin plugin. So we are going to have to use some cunning little tricks and sort of strategies, tactics that we've had to sort of learn while being Kotlin programmers.
But we do still have a refactor menu, and it largely works. So we're going to try extract superclass.
Yeah. So the first thing we'll look at is that open-closed transition, right? So let's pull out a base class. Now,
so we're going to put it in here.
What I'd like to do is pull out the base class for sign-up sheet, and that's our new base class for sign-up sheet, leaving a subclass, concrete class that holds the data and has the operations, and we'll split that into open and closed. So initially it'll be open-closed. But Kotlin doesn't have the pull out a base class, call it the original class, rename that one refactoring, which is available in Java. We're going to have to sort of like hack it in a way that doesn't break the application for too long. So let's pull out something that we're going to rename. What are we calling it? Bob.
Bob.
We'll call it Bob, and then
Bob.
It's a silly name, so we know we're going to have to change it. We're not like introducing a domain term here, and then we will come back and do the renames in a cunning way that tries not to break the application for too long.
So our aim here is for Bob to have all the operations that is common to all of our sign-up sheets. And so we think all of our sign-up sheets should have a session ID, and they should all have a capacity, and they should all have a set of sign-ups. And we're leaving these abstract so that we can define them.
You have to make them abstract explicitly.
Oh,
yeah.
when I say yes.
Yeah.
We're making them abstract so that we can use data classes to implement them in it. Okay, is closed. That is another thing that we always want to be able to ask, pretty much. Is full, I think, again, we can always ask that. And we can always ask that because we can see these sign-ups. So I think we might be able to make that not abstract.
I think we can make that concrete.
Okay, close.
Close, we want only to be available on the open state, right? So we don't want it to be pulled up.
Okay. Yeah. Is signed up? Well, we've always got a list of attendees, so I think we can always ask the question, is an attendee signed up?
And we also always want to, right? Even if we've closed it, we want to know if someone's in the session or not.
Okay. And we're not making that abstract because we think it might be able to do, like, work out what to do. Sign up. Do we always want to be able to sign up?
No.
Okay, because if we're closed, we don't want to be able to do that.
Exactly.
Okay, and cancel sign up again. If we're closed, we don't want to be able to. So this feels okay?
Okay, let's give
right.
it a go.
And so we now have a new class here, and embarrassingly, it doesn't compile. But Okay. At the moment, though, I think that should pass the test because, like, we have not really done anything. We just extracted interface. That's all good.
Okay, so now we have to use a cunning little trick. So the actual data class we want to represent, currently we're going to represent our open or closed state. So we'll call it open or closed, right? And then later, when we split out the closed state, we can rename it to open.
Okay.
But we'll just write it over the top.
And the issue here is that we want these things still to be called sign-up sheet. So if we just rename this, then it would be called open or closed. But we want this to be Bob, and then we want to rename that. So we'll get around to that. So this is going to be, at the moment, it is both open and closed, because we haven't differentiated. And that breaks these things, but now we're going to rename this.
Rename that to sign-up sheet, then that's our abstract. So that's what gets returned from our database. So we don't want to change that name across our code base.
And there's half a chance that works?
I think that's not going to work.
Okay,
partly
why not?
because, so here is where we want to actually apply this model, right? Here we've got code that's trying to sign up, but we want it to only be able to do this in, eventually, the open state, right?
Oh, so our issue here is then that this thing, the type of this sheet, is sign-up sheet, but we didn't put sign-up onto sign-up sheet, we only put it onto open and closed.
Yeah. So for now, we'll just put in a when block to say when it's open or closed, we can call something on it, and we'll keep refining that until we have our full type-safe model.
So we've got to do some irritating stuff here. So we're going to say when the sheet is open and closed, then we can do that thing. But that is, in fact, the only thing it can actually be at the moment, but it's kind of okay.
Yeah, yeah. And we'll do it down below.
Hold on. No, hold on. What else? I tell you what the problem is. Here, it's saying there could be other types that are not open and closed because we haven't made this sealed.
So if we seal something, then only the subclasses that we are defining in our compilation unit, they are all the subclasses that can possibly exist. The language doesn't, prevents us defining other subclasses. So then the compiler will give us a guarantee. You have handled all the possible cases. As we add new cases, the compiler will warn us, or will prevent us running the code if we haven't handled all the possible cases. And that's the kind of type safety we want for this error handling. Talk to me afterwards about real-world impacts of unsuccessful error handling. I'm happy to talk about that, but not on camera. So we put those explicit tests in. It's the only case we've got so far, but we're going to start splitting out more until we've built the state transition model that we want to have.
And when that says tests, it means these checks here. We're checking to see that it is this one subtype that we currently have. So if we try and run the test, so we now have another problem, which is that this thing that was called sign-up sheet is now not called sign-up sheet anymore.
And in fact, now the sign-up sheet is an abstract class, so we can't instantiate it. But what we can do is create a factory function with the same name, sign-up sheet, that takes the same arguments, but just it will create the initial state of our state machine. So for now, open and closed, and over time we'll create it'll become available as we keep refactoring. Right?
Oh, so actually the error is pretty good there. It said if you had a function that was sign-up sheet that creates one of these opens and closed with those bits, then that would compile. And it is right, by golly. I'm going to remove all the argument names, just to tighten all that up. And I think the test should pass now.
Yeah.
OK.
So we've introduced some additional structures. We've added an additional feature so that existing code continues to run. If we push that to origin and other team members pull, their code that they're writing, like creating sign-up sheets, will continue to work because of that function. Although it gets compiled to different bytecode on the JVM, it's exactly the same source code, and so we've not broken their working environments.
I'm going to commit that, I think, so that our colleagues can see the direction in which we are heading. OK, so back in sign-up sheet, we've only really actually introduced one implementation of this sealed class here, which is open and closed. That meant that we had to ask the question, is it open and closed? But open and closed we don't want open and closed, we want open or closed.
So let's copy and paste and just make a closed one.
OK, I can do that. So I'm going to copy that. I'm going to do that, and I'm going to say this one is going to be closed, which we're...
And as we did that, you'll have seen the when suddenly get a little red underline. That's a compiler saying there's now more than one subclass of sign-up sheet, and now in this in this point in the code, you have to consider both possibilities.
So just before we do, I'm going to go and rename this one to open. So that will, because that's where we're going. And in closed, I don't want to be able to sign up or cancel sign up. These are unused, and I want to keep them unused, I guess.
Yeah. And we can't close either.
OK, we can't close.
No. There are no operations. Once we're closed, we're done.
OK, so now we have to go over here and consider the other case, and the compiler will help us. It will say add remaining. OK, so when we're closed and they ask us to close, what do you think we should do?
I think we should just say OK. Right?
Okay.
This is an HTTP application. HTTP is an unreliable transport. There might have been some technical failure, a retry. The HTTP comes in, right? And at this point, because we know that we're writing HTTP, we can make the decision. The right thing to do, if we've been asked to close something that's already closed, is just to say OK. Right? Inside the actual domain model, where you don't know what context you're in, I wouldn't have wanted to make that decision, right? But outside, it makes perfect sense in the HTTP context to make that decision.
Okay, we've got another one here. So we've now got open and closed, so we can again ask IntelliJ to fill in the remaining branches, which is closed. And this closed, well, this is where we are adding somebody. When it's closed, we know we can't add someone. We kind of know that is right, right? But I guess it's a conflict. We don't have a message, but we don't need a message because we can say, cannot sign up because closed. We know that's why we can't sign up. Oh, hold on, it was going to say.
Even the AI knows.
Yeah, okay. And I think there's another one here. So this is delete, and that's the same principle, I suppose. I can just copy that one, and I can put it into here, and I can say cannot unsign up. Does that pass the tests?
Ooh. But we're not yet using the close. So what we've done is we've prepared the ground to now actually start using that new element of our model. So once we switch it in, our code is ready to use it.
Okay, so what does that mean? I guess when we were open and we closed, we don't want to still be an open one, we want to be a closed one. So we don't want to just copy this. So closed is going to need to return a closed, and that is going to then, we're going to create an instance of that. So it's going to be closed with my session ID and my capacity, and interestingly, like this has is closed as a property, but I guess
and we're setting it
that's
to false,
always,
which doesn't feel right. It doesn't feel like it should be on the constructor.
Right, so what I'm going to do is I'm going to say, I'm going to get rid of that, and I'm going to say this. If ever you ask me whether I'm closed, the answer is false. You can't set it.
No, the answer is true.
That's the one.
I'm pretty sure the test would have discovered that, but
almost certainly.
Yeah, almost certainly.
Right, but the same thing is true of open, right? So we shouldn't be able to have a subclass called open with closed being true. So that one is, I think we just move it down into there, get rid of the comma. And does that compile? Does it run? Does it work? No.
Okay, do we actually return it from? I think it's because when we return close, that would be it, yes. Lucky we've got some tests. Thank you very much.
I always program with an audience.
It's because you only program on YouTube.
Okay, how are we doing?
So I think that's looking pretty good. I think our tests are passing. I'd commit that. We've split open and closed into type-safe structures. We've pushed that checking of the current state to where we have more context and we know how to handle it properly. And now I want to do the same thing for full and available.
Before you do, though, I can't help noticing that we're saying here, check is closed, but is closed is false, so we know that that can never be true.
Okay, let's clean up.
Okay, so I have this theory that I can inline that and keep it, and then that's not check, not is false, and then if I was to inline that, then undo that. Hold on, what did it say? Remove the redundant, and then it would say, oh, well, that's false, so you can get rid of it. Woohoo! I don't like logic, I just like refactoring. And I think the same is true here, but I think I might just
Yeah.
Okay,
All right, that is cleaner. Let's commit that.
I could do a amend, but I'll let the AI work out what it was it did. And it's actually true, simplifies by removing unnecessary validations as those checks are now redundant in context.
Great.
I like in context.
Commit. And let's try the same trick now to introduce available or full, right? So we want to pull out a superclass of open, right?
Okay.
That will be called Bob or something.
Bob.
And then we'll do the rename trick so that we don't break all of our code. Then we'll create another subclass. We'll rename them so that it becomes available or full. And
okay, so it's
we'll
available or full is our
there.
problem now, because we're trying to get rid of this check is full. So that's our differentiation between our two things. Okay, so this is going to be, when we're done, well, I'm going to call it Kate this time. And so the
what do we want to
session
pull out?
IDs.
Those need to be abstract the same again. We might be able to inherit them, but I just don't trust the refactor not to break
Okay.
everything.
Is closed is always going to be...
Sign-ups should be abstract as well, I think.
What? Yes, I'm getting there. Okay. So, is closed. I don't know. It'll probably fall out, but I'm going to say
I think we pull it up as...
abstract. Find out what happens.
I don't... Oh, God, I'm confused now. No, I think we pull it up as concrete, right?
Okay. Close. Pull up as concrete.
Yeah.
Okay. Sign up, though. That's only going to be on one of them.
Yes.
But even if it's full, we can cancel a sign up, and then it will become not full. So I guess we're going to say that sign up we don't pull up, but cancel sign up we do.
Yes.
Okay.
And let's make it abstract, because we might do a copy.
Okay.
Yeah.
Let's do that. See what happens. Does that work? No. Oh, because... right. Good. Okay, so we now have another state because it's not sealed.
Yes.
So Kate has to be sealed. And the thing that we're calling open
We want to call
is now-
available.
well, it's either...
It's available or full, isn't it?
yes, it's both things at the moment because there's only one of it. So we'll call that... I'm going to call it full or not. Does that work yet?
Yes.
Oh, actually, that's...
And so
yeah,
now we
that's
can
fine.
turn Kate
Okay.
into open again.
What? Oh, so you're going to say you're going to rename this one. Do you want open?
Yeah.
Okay. And is it still working?
Yeah.
Oh, good. Okay.
And then let's do the copy, and then the renames, and then put the logic in.
Okay. So that copy is going to say this is full or not. Oh, I did. My fingers knew what to do, and I didn't. So this one is going to be
Full.
full. And full is not going to have sign up on it.
Yep.
So we can just get rid of that. This one is going to be available.
Yeah, we want to do a proper rename here, right? Yeah. So I think now our factory function above is always creating available sign-up sheets, right, which are also open sign-up sheets. So you're initially able to sign up, and there are no sign-ups, and it's not closed.
Okay, does that work? No, because now we have introduced a new one, right?
So now what do we do when it's full?
So what is this one? This is sign-up path. So we're going to say we need to handle the case of full. And if it's full now, we know that we can't do it, but we know why we can't do it. And the answer is not because it's closed, because the session is full.
Yeah.
Okay.
And I think
Any more? Okay, another one. So it is available.
I think you have to click on the
this.
when. Yeah.
Add remaining branches. Okay.
Same thing.
What? No, when I delete, if it's full, that's okay.
Oh, it is okay. Oh, so we only do it when it's open, right? With delete, we can do it whenever it's open.
Okay, so I can say in here is open. And then I can get rid of that one.
Yep.
Oh, that was nice. I like it when type systems just tell me what I should be doing. And then one more here, which is, this is what? Closed path. So this is closing. And we should be able to close open or...
All right, so we do it when it's open. Yeah.
Okay.
Done. All right, let's have a look. Oh, we're not using the new state yet, though, right?
Shall I commit it anyway? Because it feels like the test pass.
I mean, you can.
So what I think I'm going to do is I'm going to commit it, and then maybe we'll amend commit it. So commit it, not push it, but because I want to be able to come back to here if I mess it up.
I don't think it's ready for sharing with the rest of the team.
Yeah.
But I'm quite happy for you just to stash it locally in case we need to revert.
It's very generous of you. Thank you.
I wouldn't normally.
That was a good decision. Okay, going to commit that. We're going to remember to amend commit. That should be a flag. You think you should be able to say, don't push this one. Okay. Back to sign-up sheet. So it feels like sign-up app is kind of done, but we need to sort of make these types work now. So in open, we have, these are just sealed classes. That's all fine.
I think cancel sign-up should
Cancel
return
sign-up, yes, that feels like it should be available,
Yes.
because we're always going to return available from that. Close is always going to return a closed thing, okay? Sign up is going to return a sign-up sheet.
It's going to return an open sign-up sheet.
Yes. Yeah. All right. It's interesting that we don't have tests that show that these things are wrong. I don't.
But we're putting the types in so that the types checker can prove when we've got things wrong.
Yes.
And the tests then are only checking the dynamic behavior.
Cancel is going to always return available.
Yeah.
Yes, always return available. So that's we're looking for the deepest subtype that we can return, and we see that there with that copy. Good. Okay. Cancel sign up now is not just sign up sheet. That's back to available.
Yeah. So we can't copy it here. We'll have to create a new available.
Oh, okay. So what does that mean?
But maybe we can put this on open. Do you think? Because whenever we cancel in any open.
Okay.
So if we just create a new available, we can then pull it up onto the open.
Well, I'm going to make this both the same, basically.
Okay.
So this is going to say that is available with the session ID, capacity, signups, and that thing. It was really
was that
quick.
the AI doing it?
Yes, it was.
Sometimes it's.
Yeah. So
I
it
don't
remembered
trust what
that
the
bit.
AI is doing.
But that was good. That was good. Go forwards.
That does look right. Yeah.
Yeah. Okay. So I think that, and then basically we should be able to pull this up. I think. Pull members up. This is always risky, but that's going to go up. It's going to say there was another one, but now that we can get rid of because those are the same. So now cancel sign up always returns an available.
Yep. Like it.
Oh yes. Okay.
So now we just have to create the full type. It's still showing as unused.
Oh, there's a problem here though, because when we're full, we haven't got the cancel sign up on full.
Oh, because full is a kind of open, and open has cancel sign up.
Okay. But when we're available, we're not necessarily.
Yeah. So that's check is what we've got to get rid of, right? So let's pull out that as new signups. Yeah.
Okay. And now we're going to say, if new sign up size is the capacity, the AI is good for that. Then we're going to return an empty, full, which we're going to have to give the session ID and the capacity and the signups.
Yeah.
Else, that. We're going to check that.
New sign up.
Always, every time I practice this, I've done the same thing. Thank you very much. Okay, and now we've got this little lift return out of there, and then this is, I think a when.
I think that's a bit clean. Then we get rid of this brace with a Control Shift J or that. Yeah. I think that's pretty readable. I think, but that check should now be redundant, right? Let's commit what we've got, then delete the check, then
whatever.
All right.
Still good. Right. I think that is our amend on the thing we had, right? It always feels to me in this case that I'm having to do a thing by hand that the tests aren't telling me is wrong. I'm just having to design this type of hierarchy, go back to the diagram that I can't see anymore. But it's all good.
I think there is tests and test-driven development is easier to do incrementally, and types, because they're proving consistency across your entire code base, feel that they are much more of a, you put them in and it affects everything all at once. And so, we've had to find these techniques for allowing us to introduce type safety and new type models gradually without breaking everything.
If I remember, you were offended by capacity in full.
Well, capacity, fullness has an invariant, right? That the number of signups equals to the capacity. So we should just be able to return the capacity as a calculated amount.
So this is always going to be the size of the signups if we correctly went to full. So it's going to be signups.size, not that thing. Get rid of that. Get rid of that. And is that still true? So we can't do that. That.
And that works.
Good.
So that's a nice little clean
we
up.
can save some number of bytes by making that calculated.
4 bytes.
Okay. 4 bytes for the win.
Okay, so that's a cleanup. I'd commit that. Have we got rid of the check? We got rid of the check. I'd clean that. What about the catches?
Okay, so we're not actually, I'm just going to, right, let's commit that while I think of it. So we've got nowhere we're throwing in here anymore, have we? No, so we're not throwing anywhere. So this is now exception-free, but the sign-up app is still catching exceptions.
Yeah. I think we can remove those catches, but the type system can't help us. So hopefully the tests are extensive enough that if we do have any throws from anywhere, they would fail. But let's just get rid of the try.
Okay, so I'm going to get rid of that so that I've got a little block for the open, and I'm getting rid of that, and I'm going to reformat, and I'm going to run.
Okay.
Good.
Got any other catch? There's another catch above, I think. Yeah.
So there's another one. Try to remove that, that. Any more catches? No catches. No catches. No tries. There is no try.
And that's it. I think we... So, how long did that take us? Hour and 10 minutes.
30 minutes left, apparently.
So, hour and 10 minutes, we went from a bean to an object with a proper constructor, to an immutable data type with functions, with partial functions, to a sealed class hierarchy or algebraic data type with total functions, pushing the mutation and the sort of state checking to the entry point of our application, HTTP handlers, where we have enough context to know how to handle those invalid states and report them cleanly. We've got rid of exceptions and the sort of spooky action at a distance, so that makes it easier for people who are new to the code base to navigate around, because everything's tied up through the type checker. It plays well with IntelliJ, so they can learn how our application works more easily, and we can modify it and evolve it more easily because the type checker is now working for us and around our error handling.
I just did a git reset -hard without a safety net.
Okay. So, right, should we switch to Keynote? I think I just recapped, and so we can skip right over the recap slide. Okay. Yeah. So we did that, then we went back to the code, then I recapped, yes. I'm recapping the recap.
Wow,
yes.
I tuned out, sorry.
Yeah. Okay, so we first wrote this talk maybe 2 years ago, maybe 3 years ago, and of course, a lot has changed since then. So now we see this as these techniques as using traditional refactoring tools, because in the last couple of years, we've seen LLMs and especially agentic AI. If you were in this room watching Llewellyn Falco's talk about agentic AI, he was making a very good case about how rapidly it's moving. So since writing that talk, maybe these refactoring tools in IntelliJ are now, maybe they're obsolete. Maybe an agentic AI can just do the work for us, right? Maybe, Duncan, maybe you're out of a job. So let's have a look. Let's click. So we've got let's try prompting JetBrains Junie. So we're working in IntelliJ. JetBrains have their own agentic AI called Junie. This is a prompt that go up one, up one. Yeah. So here's a prompt that we could try giving to Junie that just says to Junie, that thing that just took us an hour and 10, 15 minutes, can you just do it in one go, please? I have no idea how it responds to threats. Now,
Llewellyn kept on saying please, I noticed.
Okay, see, I never say. I don't say please to you, so I don't see why I have to say it to an AI.
No.
So we're going to try it, right? AI, these LLM tools are by their very nature random. So we've run it, and we've had some results, and we're going to run it again, and what we might get might be completely different. So we're going to wing it from this point on. Also, Junie does take a bit of time. Put some blank lines in as well, because it seems to like blank lines and do different things when you don't have blank lines. Who knows why? And mirroring Llewellyn. Don't know why. And that's just the way it is with AIs, right?
What you gonna do?
As a programmer, I really don't like it when I don't know why, but let's just do it, right? We've just reverted the code base back to the beginning, right? We're going to try it again with a single prompt and see whether Duncan needs to find a new job.
So the sign-up sheet is this mutable thing.
Yeah.
This is going to take a while, so what we're going to do is we're going to take questions while it's working, and we'll come back to it and see how it's doing as we go. Okay, so Junie is sort of like one of these agentic-y things, which means the first thing it does is make a plan. So it goes off, asks somebody who knows.
And it's integrated into the IDE, so it knows about what files you have in your IDE, what it can find like README files and look at them. It can say, oh, give me the contents of this file. Oh, I want to run those tests and so on. So it works out what tests it wants to run to prove the changes it's making are correct. It will respond to any test failures in those tests, make some further edits, adjust its plans, tell you what it's doing while it's working, and then at the end present you a change set. Say, like, do you want to commit that?
Compared to like the thing we saw Llewellyn do, we can't change the plan though. So we're not. It's not making a plan and then we go, no, we don't want that. It makes the plan, takes it out of our hands, goes off and runs with it like a little puppy, and succeeds or fails. Who knows? Yeah. But you can see it's got to say. It tells you which files it's looking at, and we're running it in I'm feeling lucky mode basically, which means. If it reformats my hard disk, it's my fault. Yeah.
So it's making live edits, and it will start running the test. You might see the pop-up running. If you open up sign up app and sign up sheet, you'll actually see the edits coming in as it's doing it. It's easier. I find it easier to look at that than the diff. But anyway,
I mean, quite amazingly, it has gone straight to sign up sheet with. So you can click on the diffs here and see. It's gone straight to sign-up sheet as a sealed class with all these bits straight inside it. So it never even tried the data class, because why would it? It's all seeing. I for one welcome our new AI.
And it doesn't care at all about team members, right? It's just I'm going to make one massive change set, cross the code base, smash it all in.
Will it be looking at your Git repo? Because
no.
Having a name is exactly.
Yeah. It's creepy.
Well, we have names in the tests, right? So it's looking across the entire code base to get naming.
No.
No, but we have things like is full, is closed, right?
Yeah. But we're suspicious as well.
Yeah, but we are a bit suspicious. Yeah. Anyway, while that's working, we don't know how long it will take because it goes off in different directions depending on how it's broken the tests and how it tries to repair them. Maybe we can have some other questions if anyone has any.
The audience, then raise your hands. Otherwise, I have some from Slido.
Splendid.
So first one is how much overhead does copying immutable data structures give?
Well, if you're working in enterprisey sort of code, probably very little compared to your logging library. So, it's probably not very noticeable. If I was working in an embedded system or huge data sets, then I might do it differently. But we're running on hotspot, so it's got the Eden space, which is just a stack to allocate. It's got escape analysis. It's very difficult to tell with these things until you've run it on hotspot and profiled it and seen where the hotspots are. Yeah. But I've not had a problem in the kind of software that I write, and in the kind of software that I write, the problems I get are people writing logic wrong because they don't understand how the application works.
I think it is true. There are two parts of overhead. One is how much more memory does it use and how much time does it spend copying that stuff around. I think certainly on the server side, we are fundamentally, there is never any shared state between requests. And so everything happens in a request and is thrown away at the end of the request. So we don't really see any issue with memory pressure due to the copying. We don't see any performance, given that all of the big data is almost always byte arrays or strings or things that you are simply just moving a reference around to. That doesn't tend to be an issue either. It is true to say that the the paradigm of object-oriented programming where we were mutating things was invented when we didn't have a lot of memory and copying was expensive. So it was natural to just mutate things. These days we do live in a time of plenty, and things like the JVM are so sophisticated with respect to, does this ever escape a stack frame? Is it ever saved anywhere? That often these things are never even really created on the heap.
Okay. What happens with an unexpected exception coming from the business logic? Will the HTTP server crash?
Well, in that application, so an HTTP app is a function from request to response, and it's run in a server. And that server, Jetty or Tomcat or Undertow, whatever, has a top-level exception handler where any kind of exception that gets that far gets turned into a 500 technical error. So what would happen is, when run in a real server, any unexpected exception would be turned into a 500 error by the infrastructure that we're running on top of. Right? And it's a good question. Right? Like it's, there are like the way I see it is, we have these technical errors that, maybe our database connection would fail, and there's a technical sort of infrastructure layer, and our application is sitting on top, and an exception might bubble out of that technical layer, or there might be an actual bug which we can't predict. It will rip through back into our runtime where it's handled in one place. There's one place in a web application. We know what to do with those kind of errors. They turn into 500, and that does the right thing. Clients know that there's a 500. Maybe they retry in an hour or something, right? While business logic errors, where I want to actually explicitly do specific logic, and in this case, convert particular error cases coming out of my code base into correct HTTP responses, and if I get them wrong, I might cause request storms or whatever in my network. Those ones I want to type check. I want them to be easy to test and type check. And so, by modeling them this way, I get the help from my tooling, my compiler, to get them right.
Before we go on, I should say that Junie has finished.
Well, let's see what it's done.
Should we have a little look? So, first question, it says it's done. Second question, passes the test. Third question, what does it look like? And so it hasn't made the session ID immutable, non-nullable. Humans won, AI nil at the moment, but we have a sealed class for the sign-up street. Inside that, we have the subtypes of it, which is legit. We have a function, this companion object function create rather than the one that we created at the top level. So that would have smashed a change across the code base anywhere that was trying to create a sign-up sheet. So it's not taken as much care. I could probably try a different prompt to get it to be a bit more sensitive about its impact on the wider team members. But it's not terrible. It's better than I would expect. And fundamentally it works. So there are a few interesting things like is closed. Get this is closed is an interesting sort of little
that
wrinkle.
Is interesting, yeah.
I think that's the thing we didn't finish in hours that we could have in place of is closed. We could have asked whether it was an object of the closed state.
Yeah, because closed was only true in the closed class and false in any other class. So yeah, that works. Yeah.
But I mean, very very similar to our code, used an if rather than a when, but
yeah. So there's little bits of cleanup you could do.
It didn't mess up the new sign-ups. It put the right one in here. It's brilliant.
So it's better than you.
Yeah.
Also what does the app look like?
Yes, in the actual app.
Does it remove all the exception handling like I asked it to?
It does, yes.
It
So there we go. Yeah. And you can see even here like this. I don't know whether it was watching when I typed. It's sometimes suspicious, I've got to say. But yes, it has created an updated sheet and said, okay, I need to save that updated sheet. It's just a little bit creepy.
Yes, it is.
Quite frankly.
Yeah.
Shall we go on to more questions?
Yeah, there's one more. If you bring back the slide. Oh, then I give you the mic. You have a question?
Well, no, as a sort of a remark, there must be
some relation to what you've done before,
Yeah.
maybe multiple times, and what it did, because updated sheet is...
Yeah. To quote Llewellyn Falco, I just don't know. So, yeah, I mean, that is the problem. These things are big, they're complicated. Who knows what data it's looking at? It's not clear. It could, like IntelliJ, for example, maintains a local history separately from Git. So even when I revert Git, it's recorded that history against all my actions, and I can go, oh, let me go back to just before I reverted in Git, and then it will so maybe it's looking in that, maybe it's not. I just don't know. Yeah.
So the local LLMs, the bits that you get when you do dot and complete.
Yeah.
I have a suspicion. So when I make videos, I will have I'll have rehearsed it once or twice, and I have a suspicion that it's like those are completing from rehearsals. It just feels that way. But updated sheet is the natural name for this, right? What is it? It's the updated sheet. It's the name I gave to it. It's the name that I think functional developers would give to it. So it's always, yeah.
I would suspect that it would be more similar to what you do with the sheet in it. So there would be something like
Yeah.
sheet with science.
Yeah, I mean, if
Maybe.
it was truly functional programming, they'd call it Sheet Prime or something like that, wouldn't they?
Yeah. Well, they would I mean, let's face it, they would have inlined it like I did because, why have it?
Yeah. So there's a bunch of things I don't like about that code, but it's a lot nicer than the code it started with. It's made us go very fast. I don't know what the impact will be on teams if all team members are making changes this big, right? We know, or at least our current understanding of the best way of working on software in teams is lots of small commits that interleave and safely, right? That are cheap to revert, that we do continuous integration as rapidly as possible. And my rule of thumb is, right, if you've got a merge conflict, if it's not cheaper to throw away one of those conflicting changes and rewrite it, you're not doing integration frequently enough, right? So continuous integration is you do it so frequently that when you've got a conflict, it's cheaper to throw it away and do it again, right?
I was going to say, we don't need no stinking other developers. We've got an AI.
But, well, exactly, right?
How many developers are doing that in your...
Yeah, 20,000 developers. Yeah, I don't 8, but yeah. No, I don't. Yes, and that's what continuous integration should be, and it's a challenge even now. What, like 25, 30 years since the idea was first mooted, right? So, but with LLMs, will it get worse? Will teamwork get harder because people are making bigger changes and then worrying more about trying to merge them together and then using LLMs to merge them, making the changes even bigger? I just don't know, right? So that's one of my worries. But, yeah.
First of all, thank you. It was great. Very impressive, I have to say. Basically, lots of distractions, no mistakes from your side. That was crazy. I'm not sure how valid my question is, but always when I see sealed class hierarchies compared to what I was taught back in the days to create polymorphic object structures, getting rid of switch statements, putting the if statements to factories, and then generating basically polymorphic object structure out of it, and then based on that, you just use the polymorphic object and then call the methods on that.
Mm-hmm.
Now these when statements seem to kind of go all over the place.
But I think that what's different is we have sealed class hierarchies, right? So we know there's only a limited number of types, and we know that if we add another type, that the compiler will tell us that we've done it right or wrong. The problem with arbitrary type checks in, say, Java, which doesn't have sealed classes, I think it might in recent ones, does it?
Does it?
Yeah, so it does now, but it didn't in the day when I was using Java, is that you just don't know whether you've covered all the cases, right? So when I'm trying to argue hey, let's do sealed class hierarchies and whens, and I sort of describe it as, well, this is the visitor pattern in the language, right? We would write this kind of thing using the visitor pattern, right, so that we knew that we were covering all the cases when we only had Java-style OO. But now, we get that coverage with the when statement, and sort of it's the same as the visitor pattern, but much less code, right?
One more on Slido. basically you're relying on the instance of operator, which is quite expensive from performance point of view. Couldn't that be a problem at larger scale?
Yeah, I don't know how optimized it gets. I mean, I would guess, but it's true. I've not looked at the bytecode and I've not profiled that aspect of it. But the seal class hierarchy should mean that it's just not arbitrarily running up enormous class hierarchies. There's only, like in this case, I think 5 classes to look at. So it's not something I've ever really had a problem with.
I mean, I think the other thing that's really expensive from a performance point of view is throwing exceptions. And so now, obviously, you could not have those exceptions thrown by asking the question before you perform the operation, now am I in the state to do that thing? So if you really want performance, you could have the mutable class and not the instance operation and not the exceptions. But this is a sweet spot, for us at least, for systems that are understandable, also systems where basically when you type dot, you get the right thing. Yeah. And we like just, given, if we can't mess it up, we can't call the wrong thing. It's a sort of low friction, type 1, easy heuristic programming model. It keeps you in the flow. It's really nice. Any more?
More questions?
Do not feel embarrassed by letting us go early because this was a 2 slot. Yes, go on.
Do you the LLM created companion objects?
Mm-hmm.
Do you ever use them?
Companion objects? Yeah. Oh yeah, a lot. Yes. They're
because they seem like sort of useful for factory functions, and factory functions are just functions, so you don't really need companion object for that.
They're nice because they're an object, therefore they can implement an interface. So imagine if Java statics could also conform to an interface and then be passed around. You can do the same thing with companion objects. It is the only way really to do statics inside a class, inside Kotlin. You can have top-level definitions as well, which I use much more often. There are different ways of doing it. So we chose to define a function to act as a factory function. We could have defined operator invoke on the companion object, or even make the companion object implement a function interface so that it implements a function type and is a function that can be passed around. Either of those would have had the same syntactic structure, right, and not broken code, different JVM bytecodes. But a function was easy to write, so we did it, right? But there are other things you can do too.
Another trick is that you can, once you have a companion object, you can create extension functions on it, which appear then to be new static methods, but you can do it from outside, so you can do that sort of thing.
So quite often just create an empty companion object. Unfortunately, Kotlin doesn't by default or synthesize them just like on the fly as you need it, but just being able to add, have say, in my database domain, I've got some or appear to be static methods of this class, and in my user interface domain, I've got static, and that is like a really powerful sort of programming idiom inside Kotlin.
There's a proposal to make companion objects appear if you pretend you need them. So rather than actually having to put them in every class, if you say I'm going to add an extension to this companion object, the compiler will say, okay, well, I might as well generate one for you. Then what's the harm?
But they add to sort of, discoverability, right? So it's harder to find a top-level function, but if you know, I want to do something with this object or this type, and you start with the type dot, and then the IDE will show you all the things you can do.
Then the question is, why do you? Yesterday in the workshop, you moved to top-level functions. And you just said that you are using them more often than before. So then, it's sort of a choice between one or the other.
Taste.
It's taste, isn't it?
It's taste, yeah. If you're writing a library that lots of different people are going to use, who maybe don't ever speak to you, then companion objects are really useful to add and hook these additional helper functions on, because it will help the users of your library find that more easily. HTTP for K does that a lot, and it's where I learned the technique from. In an application where it's a small, tight-knit team, maybe you don't need to do it so much, right? It's context.
I think we're in the weeds now. Talk to us later. Thank you all for being so attentive.
Thank you
You
for
have
your
any more?
talk.
Thank
I give a
you.
round of applause, and thanks for all the energy. And just give me a moment.